Today's lesson 37, and the title of it is Differentiation by U Substitution. So instead of just differentiating whatever the problem is, it's going to be a little bit more complicated. So what we'll do is we'll make a substitution for the complicated expression. We'll take the differential of that, and then we can find the derivative of the U substitution. So if you look on page 197, the original problem is f of x is equal to x squared plus 2x to the 10th. And it says to find f prime of x. Well, we don't know how to find the derivative of something that complex. So instead, what we're going to do is we're going to take u equal to what's inside the parentheses. Always what's inside the parentheses. And while you're at it, go ahead and find du, which is the differential. So du would be 2x plus 2 dx. And just hold on to these because we're going to use these in just a little while. Going back to the original problem, now I'll just change f of x to y. Y is equal to not x squared plus 2x to the 10th, but u to the 10th. And now we can find dy. dy is equal to 10 u to the 9th du. And at this point, all we need to do is substitute back the u and the du, and we'll have dy dx is equal to 10 times u was x squared plus 2x to the 9th power times du, which is 2x plus 2. And then you can simplify that because we could factor a 2 out of this. So that would be 2 times x plus 1. And then if we take that 2 and multiply it times the 10, it'll become 20. Actually, we can factor out an x here as well. So this would be an x, and then times x plus 2 to the 9th. This is x to the 9th. I better show you this on a different screen. When we had 20, and then x squared plus 2x to the 9th times the x plus 1, we can further simplify that by factoring an x out of here. But when we factor the x out of here, it's x to the 9th. And then there's an x plus 2 left over. So when I simplify this, this will be 20x to the 9th times x plus 2 to the 9th times x plus 1. And that's dy dx. And you really do need to simplify it that far. All right, so the next one is h of x is equal to the cube root of x squared plus 2x, and we're supposed to find h prime of x. So the first thing I'm going to do is rewrite this as h of x is equal to x squared plus 2x to the 1/3 power. And then we'll make the u substitution. So u will be equal to x squared plus 2x, making du equal to 2x plus 2. And this is now u to the 1/3. All right, so now dy will be equal to 1/3 u to the minus 2/3 times du. And at this point, we just plug back in what we have. So dy dx will be equal to 1/3 times x squared plus 2x to the negative 2/3 times the 2x plus 2, which we can factor the 2 out of here and multiply it here. So dy dx will end up being 2/3 times x squared plus 2x to the negative 2/3 times x plus 1. And we're not going to factor anything out when it has a fractional exponent power on it. All right, the next one is g of x is equal to ln of x squared minus 42. Find g prime of x. So I'm going to say u is equal to x squared minus 42. Du will be equal to 2x dx. And I can go back and say the original equation is y equals ln of u. So then dy will be equal to 1 over u du. And plugging back in the u and the du, we get dy over dx is equal to 1 over x squared minus 42 times the du, which was 2x. So we can just write that together as 2x over x squared minus 42. All right, on page 198, the next one says f of t equals sine of t cubed minus 15. And it's looking for f prime of t. So I will say that u is equal to t cubed minus 15. So du is equal to 3t squared dt. And then the original problem becomes y equals sine of u. So dy is cosine of u du. And plugging back in our substitutions, we'll have dy dx is equal to cosine of t cubed minus 15, and then that whole thing is times 3t squared. And it just looks awkward to have the 3t squared out here because it almost looks like it's multiplied times the t cubed minus 15. So I'm going to rewrite that and pull the 3t squared in front of the cosine of t cubed minus 15. Okay. Then we have y equals sine cubed of x. Now remember, that's like saying y is equal to sine of x cubed. So u will be sine of x, and du will be cosine of x dx. And the original problem is y equals u to the third. So dy is 3u squared du, and then plug back in. So dy dx is equal to 3 sine squared of x times cosine of x. So see, the U substitution problems in some respects are easier than other differentiation problems. Next, it says y is equal to cosine of e to the x. Now, I don't know how to find cosine of e to the x, so that tells me that my u substitution needs to be e to the x, and du will still be e to the x dx. The original problem becomes cosine of u, so dy is negative sine of u du, and dy dx will be equal to minus sine of e to the x times e to the x, but that looks strange again, so we'll put dy dx is equal to minus, bring this in front, e to the x times sine of e to the x. All right, bottom of page 198. Y equals e to the x plus 1 raised to the 1/2 power. So again, the u becomes what's in the parentheses. So then du will be e to the x dx. And the original problem is u to the 1/2. So dy is 1/2 u to the negative 1/2 du. And then dy dx will be equal to 1/2 of e to the x plus 1 to the negative 1/2 times e to the x. And now that negative 1/2 power can go to the denominator, and the e to the x will be in the numerator. So dy dx is going to be equal to e to the x over 2 times e to the x plus 1 to the positive 1/2 power. All right, one more. Find dy dx when y is equal to ln of the absolute value of cosine of x. So u is cosine of x, and du is minus sine of x dx. And the original problem is y equals ln of absolute value of u. So then dy becomes 1 over u du. Really, the only reason that we have the absolute value in the beginning is that we can't take the natural log of a negative number. So if it was a negative number, you'd have to take the absolute value of it in order to continue. All right, so then dy dx will be 1 over cosine of x times negative sine of x. But negative sine of x over cosine of x is simply minus tangent of x. All right, so that's it for lesson 37, and it's not due until Tuesday after the test.